So guys, now we are actually coming to the mid of the chapter where we are going to discuss some of the important concepts, and those concepts are related with the second period elements, especially lithium and beryllium. Since size of the lithium is smallest in group 1 and it has unavailability of vacant d orbital and comparatively high electronegativity, lithium shows anomalous behavior than that of the other elements of group 1. So, when I am talking about anomalous behavior, so what are the reasons? The first reason, smallest atomic size. Second reason, highest electronegativity. Third reason, unavailability of d orbital. So there is no d orbital at all. And lithium atom interaction is strong. Because small size, so there is a strong atom-atom interaction. So lithium is actually showing a variety of properties which are not shown by the rest of the alkali metals. So the properties, the anomalous properties of lithium are covalent nature of lithium compounds. Because of the small atomic size, Fazan's rule, when we apply, lithium forms mainly not a covalent compound, ionic compound, but having a more covalent characters. Okay. Then lithium hydroxide is weak base as compared to the other metal hydroxides. Lithium sulfate, Li2SO4, sparingly soluble in water as compared to the other metal sulfates are easily soluble in water. Lithium carbonate, sparingly soluble in water, and it can undergo decomposition, giving you lithium oxide and carbon dioxide, okay, on heating, while other alkali metal carbonates are highly stable. Even at a high temperature, they never undergo decomposition. Then lithium form normal oxide, while other alkali metals also form peroxides and superoxides. Lithium nitrate undergo decomposition, giving you lithium oxide plus nitrogen dioxide and oxygen. Okay. While other metal nitrates, for example sodium nitrate, on heating gives you sodium nitrite. on heating. Then, being covalent nature of lithium compounds, many of the lithium compounds like lithium chloride, lithium halides, lithium carbonates, lithium hydroxide, lithium sulfate are soluble in some of the organic solvents also. Okay. So, just writing lithium halide soluble in organic solvent. Okay. While other metal halides are not at all soluble in organic solvent, they are completely soluble, easily soluble in water. Okay. So, this is all about the anomalous behavior of lithium. Now, let us consider one more concept which is related with the lithium. So, we know that lithium, beryllium, then here we have a sodium and magnesium. This is from the second period and this is from the third period. As we move across the series, atomic size goes on decreasing. So, lithium must be the largest one in second period. While here magnesium is smaller than sodium. It is so smaller that atomic size, atomic or ionic sizes of lithium and magnesium is approximately equal, nearly equal. This is called as diagonal relationship in a periodic table. Since their atomic sizes and ionic sizes are same, their properties are also same. So, what are the different characteristics of lithium and magnesium where they have a similarities? And that similarity is because of diagonal relationship. So, the first one is lithium bicarbonate and magnesium bicarbonate both are actually exist in aqueous solution. Rather, we can say this way, this is also one of the anomalous behavior, because all other bicarbonates are solid state in alkali metals, while lithium bicarbonate exists only in a aqueous solution. There is no solid state. So, lithium carbonate undergo decomposition on heating, giving you lithium oxide and carbon dioxide, same as that of the magnesium carbonate. So, Li2CO3 on heating gives you Li2O plus CO2, while in case of magnesium carbonate we are getting MgO plus carbon dioxide decomposition. Similarly, lithium nitrate undergo decomposition, giving you Li2O plus half O2 plus NO2. Same way, magnesium nitrate undergo decomposition on heating, giving you magnesium oxide plus half O2 plus 2NO2. Similarly, if we are talking about lithium sulfate, that also undergo decomposition, giving you Li2O and sulfur trioxide, while magnesium sulfate also undergo decomposition as magnesium oxide and sulfur trioxide. Lithium reacts with nitrogen, so as the magnesium also, and giving you. So, lithium reacts with nitrogen forming lithium nitride, so as the magnesium also forming magnesium nitride. So Li plus N2 gives you Li3N, and magnesium gives you this one, magnesium nitride. So this is all about the diagonal relationship for the lithium and magnesium and anomalous behavior of lithium. So now we will discuss the anomalous behavior of beryllium. Same reasons, smallest size in a second group, unavailability of vacant d orbital, highest electronegativity, and the interatomic distance is also very small, and the strength is also very high. Because of that, beryllium is showing different properties than the rest of the alkaline earth metals. So what are those properties? The properties are, first one, it is hard metal. It is hard metal. Being strong atomic interaction, beryllium becomes a very hard. While the rest of the metals are comparatively less harder, like magnesium is a brittle in nature, okay, calcium is somewhat soft, and so on. Next one, it forms a covalent compounds. Okay, and since the covalent compounds are formed, many times those compounds are easily hydrolyzable. For example, beryllium carbonate, when reacts with water, it actually gives you beryllium complex CO2. Okay, so because of this reason, we can say 4H2O this way. So these compounds, while other alkaline earth metal compounds are ionic in nature, they are not easily hydrolyzable. Okay, other metal compounds are ionic. Next, beryllium actually form oxides and hydroxides which are amphoteric in nature. So beryllium oxide and beryllium hydroxide are amphoteric in nature, and the rest of the metal oxides and metal hydroxides are actually basic in nature, alkaline in nature. Okay. The highest coordination number is 4 for beryllium, while for other elements, for other metals, alkaline earth metals, it is 6, and it is due to availability of vacant d orbital in other alkaline earth metals. BeCl2 is covalent, while other metal chlorides are actually ionic in nature, and it forms a breech structure like this way. So polymeric, dimeric structure of BeCl2 in a vapor state. Beryllium carbide when reacts with water gives you methane plus beryllium hydroxide. While other carbides when react with water gives you acetylene. So these are some important anomalous properties of beryllium. Now, so here we go again, lithium, beryllium, boron, then sodium, magnesium and aluminum. So as we discuss about these two, lithium and magnesium, similar trend is observed in a beryllium and aluminum. Because their atomic sizes are similar, their properties are also same. So this property is called the diagonal relationship between beryllium and aluminum. So what are the similarities in the properties? First one, beryllium oxide and aluminum oxides are hard and high melting point. Then beryllium oxide, then beryllium hydroxide, aluminum oxide and aluminum hydroxides are amphoteric in nature. Okay. So beryllium form dimeric structure, a similar structure is formed in an aluminum chloride in the vapor state. This way, dimeric form. Okay. Both the form covalent compounds. Okay. In both the cases, the chlorides are soluble in organic solvents and they are little bit sparingly soluble in water. So this is all about the diagonal relationships of beryllium and aluminum. So guys, now we are going to discuss some of the compounds of alkali and alkaline earth metal. The first compound which we are going to discuss, that is sodium carbonate. Now sodium carbonate actually found in a decahydrate form. So it is prepared by various methods, but one of the important method which is commercially used for the preparation of sodium carbonate is solvage process. In a solvage process, they are actually using brine, that is sodium chloride solution, then calcium carbonate and ammonia. These are the three main raw material used for the preparation of sodium carbonate. So this is the flow chart of for the solvage process for the preparation of sodium carbonate. Interestingly, the product sodium carbonate is obtained because of sodium bicarbonate. So the person who want to go for only sodium bicarbonate can stop there. If you want to go for sodium carbonate, you can continue after heating sodium bicarbonate, you will get sodium carbonate. So, this is the process which we have to discuss. So, we will start with the first form, calcium carbonate. Calcium carbonate on heating undergo decomposition, giving you calcium oxide and carbon dioxide. Calcium oxide react with water, giving you calcium hydroxide. Now, calcium hydroxide when react with ammonium chloride gives you calcium chloride and ammonia. Ammonia which is liberated is passed through a solution of brine, that is sodium chloride solution. Now, ammonia, carbon dioxide which is coming over here react together, giving you, first actually it gives you ammonium carbonate, ammonium bicarbonate. Ammonium bicarbonate is then converted into sodium bicarbonate, and ammonium carbonate is converted into ammonium chloride. So, it is very interesting, whatever the material which we are using, unless and until we are not finishing the sodium chloride, the all other raw material we are reusing it. So, once the sodium chloride is complete, we can, that process will stop. So, here if you observe here, ammonium chloride is formed. That ammonium chloride further again react with calcium hydroxide which gives you ammonia, pass through sodium chloride. Now, when we are getting sodium bicarbonate, baking soda. So, if anybody wants to prepare a baking soda, that fellow can stop here. Now, after heating sodium bicarbonate which undergo decomposition, giving you sodium carbonate, decahydrate. Now, in doing so, there is a loss of carbon dioxide which we can reuse again here, which can pass through the sodium brine solution. So, here there is one recovery tower. In a recovery tower, after this we have a recovery tower, we are actually recovering ammonium chloride and carbon dioxide. This is all about the solvage process. Now, what are the reactions, important reactions of sodium carbonate? Sodium carbonate forms an alkaline solution, basic solution in solution. Therefore, it was initially used in a washing for washing purposes. So, this is a washing soda. Now, sodium carbonate when heated below 373 Kelvin, 9 water molecules are lost and there is the formation of sodium carbonate monohydrate. Now, this is a crystalline which on further heating above 373 Kelvin, there is the formation of amorphous sodium carbonate. Sodium carbonate when dissolved in water gives you alkaline solution, as we have done in hydrolysis. The hydrolysis process is taking place because sodium carbonate is a salt of weak acid and strong base. Weak acid is carbonic acid. Sodium carbonate react with calcium hydroxide and there is a precipitation of calcium carbonate. Sodium carbonate when fused with a silica, you will get a sodium silicate. So, that is one of the important steps for the preparation of glass. When sodium carbonate, through the solution of sodium carbonate, when a carbon dioxide is passed, the precipitation happens and that precipitation is because of sodium bicarbonate. Sodium carbonate is more soluble than sodium bicarbonate, hence that precipitation happens. Similarly, sodium carbonate when react with calcium chloride, again we are getting calcium carbonate. When it react with HCl, first it gives you sodium bicarbonate and later on it gives you sodium chloride with the evolution of carbon dioxide. So, almost all carbonates, calcium carbonate, sodium carbonate, potassium carbonate, whenever they react with acids, actually liberates carbon dioxide. So, that may be a test for the carbonate ions. So, this is all about the sodium carbonate and rather we can say sodium bicarbonate also. So, for the preparation of sodium carbonate and sodium bicarbonate, only this method is till now used for commercially. Reactions, if we consider the reactions of sodium bicarbonate, the similar reactions are taking place. Only the thing is that sodium bicarbonate on heating gives you sodium carbonate. Few more examples we have to discuss, that we will discuss in the next session. Thank you.